This video is a review of factoring. So for my students, I'm going to work out the odd problems and they're going to do the even problems for their assignment. So in these problems, the instructions are to just factor the following polynomials by determining a greatest common factor. So when you look at number one, you might think that you could do the difference of squares here, but you cannot because 21 and 15 are not perfect squares. So all we can do is factor out a greatest common factor, which in this case would be 3. So our answer is simply going to be 3 times 7x minus 5y. So all I'm doing is dividing each of these terms by the greatest common factor, which is 3. On the next one, I have a 5 and a 12 and a p squared and a q squared. So is there anything that I can factor out of that? And the answer is no. The factors of 5 are 1 and 5, and neither of those are factors of 12. So for this one, you would simply write prime as your answer, and that means that it cannot be factored. All right, on the last one here, number 5, you have a 10, a 9, and you don't have a coefficient on this, so we're not going to be able to factor out a number here. So let's look at the variables. Each of these has, at a minimum, an A and a B. So there's an A here, and there's a B here. So we can factor out AB. So we're going to divide each of these terms by AB. So that would give me 10. A squared divided by A leaves me with A. B squared divided by B leaves me with B. Divide out an A and a B here, and you're left with 9B. A divided by A would just leave you with 1, so the A goes away, minus A. So again, A squared divided by A is A. B divided by B is 1, so it just goes away. So the next set of examples we're going to do are difference of squares. So difference of squares always involves subtraction, and the two terms here are perfect squares. So you're just going to take the square root of each of these, and your answer will look like this. So the square root of a squared is a. The square root of 64 is 8. So I'm going to write that twice. And one of these is going to be plus, and one of them is going to be minus. And remember, you can check your answer by using FOIL. So remember, FOIL would be first. So I do a times a is a squared. Outside, that would be minus 8a. Inside would be plus 8a. And last, so FOIL, first, outer, inner, last, would be minus 64. These would cancel out, and you'd be left with what you started with. So remember, on all these problems, you can check your answers. All right, so number 9, the square root of m squared is m, the square root of 81 is 9, but this is plus. The difference of squares only works if this is subtraction here. So the answer to this is going to be prime. We can't factor that. Number 11, the square root of 16x squared is 4x. The square root of 49y squared is 7y. Again, I'm going to write this twice, and one of them will be plus, and one of them will be minus. Now, one thing I see students do is change the order of these sometimes. You can't change the order of this. So it needs to be 4x plus 7y, not 7y plus 4x. So don't change the order. Keep them in the order that they were given to you. And then the last one, c squared. So the square root of that is c. Square root of 81d squared is 9d. So c and 9d. And make one of them plus and one of them minus. And it doesn't matter if you make this one minus and this one plus. Still work out okay. All right, so now we move into trinomials. And so with trinomials, what you're looking for are two numbers that multiply to make 6. Sorry about that beeping noise in the background. So they multiply to make 6, and when you add them, they make 7. So you have 3 times 2, but those don't add to 7. 6 times 1, those do add to 7. So your answer would be x plus 6 times x plus 1. And again, remember, you can FOIL this to check your answer. So if I was to FOIL this, x times x, so first would be x squared. Outer, x times 1 would be x. Inner, 6 times x would be 6x. And last, 6 times 1 would be 6. I ran out of room here, but you can see if you combine these like terms here, you would have x plus 6x is 7x. So you'd have x squared plus 7x plus 6, which is what we started with. So you know you did this correctly. All right, so we're looking for two numbers that multiply to make 16 and add to make negative 10. And multiply to make positive 16 and add to make negative 10. The answer would be negative 8 and negative 2. So negative 8 times negative 2 is positive 16. Negative 8 plus negative 2 is negative 10. So our answer would be y minus 8 times y minus 2. And again, if you wanted to check this, you could FOIL it. It doesn't matter the order here. So if you wanted to have y minus 2 times y minus 8, that would be fine. All right, so on number 19, so they multiply to make negative 45 and add to make negative 12. So I'm thinking 15 and 3. So 15 and 3, I need them to multiply to make a negative. So that means one of them is going to be positive and one of them is going to be negative. And I need them to add to make negative 12. So that means I need the larger number to be negative. So 15 and 3, and I'm going to make the 15 negative and the 3 positive. So that gives me c minus 15 times c plus 3. 21. So negative 30 multiplies to make negative 30, and actually multiplies to make negative 30b squared. Okay, and then it adds to make 13. So I'm thinking 6 and 5, that doesn't work. How about 10 and 3? Would that work? No, because one of them's got to be positive, one of them's got to be negative for this to be negative. And I add those together, I'm not going to get positive 13. So what about 15 and 2? I want the addition to be positive, so that means I want the bigger number to be positive. Sorry about my dog barking in the background. So I have a plus 15. Hold on, I'm going to yell at my dog. Willow, Willow, stop barking. Well, that didn't work very well. And then times a minus 2. So if I multiply a positive 15 times negative 2, that'll give me negative 30. And if I add them, that'll give me positive 13. But what did I forget? I forgot about the b squared. So let's fix this. So what I need to do is do 15b minus 2b. So when you multiply those together, you're going to get negative 30b squared. And you might be wondering, well, what about this AB here? Well, let's FOIL this and see what happens. So if we FOIL this first, a times a is a squared. Outer, a times negative 2b would be minus 2ab. Inner would give me plus 15ab. Do you see where the ab is coming from now? And then minus 30 b squared. Combine like terms here. You have a squared plus 13ab minus 30b squared, which is what we started with. Okay, so that's how the AB here works out. So when you're thinking about adding these to make 13, don't worry about the AB. Just think about the positive 15 and the negative 2. But don't forget the B here for this last term. All right, so the last piece here is find a greatest common factor first and factor that out. And then you're either going to do difference of squares or you're going to have a trinomial to factor. So on the quiz that we're going to have on this in my class, you should always check to see if there's a greatest common factor first. So we got 75 and 48. So greatest common factor would be 3. So let's factor out a 3. So divide them all by 3. You'd have 25 r squared minus 16. And now we have a difference of squares here. These are perfect squares, 25 r squared and 16. So now we're going to do difference of squares, and this 3 is just going to stay out here in front. So the square root of 25 r squared is 5r. The square root of 16 is 4. And remember, when we do difference of squares, we just write that twice. And one of them is plus, and one of them is minus. And that would be your solution. If you wanted to check this, you would do FOIL on this, and then multiply everything by 3. And it would take you back to where you started. All right, on 25, I can factor out an m out of this one, and I can factor out an n. So we're going to factor out an m and an n. So m, n. So that leaves me with m squared minus n squared. Again, we can use difference of squares here. These are perfect squares. So I have my m n in the front. Square root of m squared is m. Square root of n squared is n. Difference of squares, remember you're going to do this twice, and one of them is plus, and one of them is minus. So now we have a trinomial. So on a trinomial, what can we factor out? 3. So we can bring a 3 out. So divide all the terms by 3. X squared plus 5x minus 24. All right, so now I'm looking for two numbers that multiply to negative 24 and add to positive 5. So I'm thinking 8 and 3. One of them's got to be positive, one's got to be negative. It's a positive 5, so the bigger number needs to be positive. So it's going to be positive 8 and negative 3. So x plus 8 times x minus 3. I don't think my dogs agreed with that. So there's another one. Okay, so there's no coefficient here on the 29, so I can't factor out a number. Let me yell at my dog one more time. Sorry. Hey, stop barking. Hello. I actually have 4 dogs. That's the problem. So there's no coefficient here. I can't factor out a number, but I can factor out an x. So let's take out the x. X squared plus 9x minus 52. So looking for two numbers that multiply to make negative 52 and add to make 9, positive 9. So about 14 and 3. No, that doesn't work. Let's see, I'm gonna have to, so if you're not sure of factors, just start plugging numbers into your calculator. Let's see what we get. So what happens if I do 52 divided by 3? Oh, that's a decimal. About 52 divided by 4. That's 13. So 13 times 4 makes 52. So positive 13 and negative 4. So we have, sorry, that's terrible. X there. So we have x times x plus 13 times x minus 4. All right, so that's a review of factoring. For my students, you're going to do the even numbers now.